Alrighty, so I figure I might as well. Well, I mean, I wanted to get through Dell 10, recording one video, and speed that up 1,000%. But instead, I got 2 hours of dibble dabbling around, and then it's at 200%. So it looks almost normal speed. Pretty cool, right? Yeah. So, miscellaneous. The other was. I thought I was done with this. I'm just gonna. Yeah. Material options. The options available when importing material using FBX are explained below. Search location. Specify where we should search for matching materials when importing. Search local. Search for matching material in the local import folder only. Under parent, search for matching material under cursively from parent folder. Under root, search for matching material cursively from root folder. All assets. Search for matching material in all asset folders. Material import method. Specify the import method for the following options. Create new materials. Automatically creates a new material asset from import. Create new instance materials. Enables selection of base material name. Do not create material. Do not create a new material asset from import. Import textures, if enabled. Textures referenced in the FBX file are imported into Unreal. If import materials is true, textures are always imported regardless of this setting. Invert normal maps. If enabled, the textures are being imported. Normal maps values will be inverted. Reorder materials to FBX order. If enabled, the material list will be reordered to the same order as the FBX file. Naming rules. The table below shows how the various content types will be named when the override full name is enabled. Table assumes the following. 1% is the name of the asset being imported, i.e. the last part of the import path. Modelo 2 is mesh name in the FBX file. For skeleton mesh, it is composed of multiple FBX meshes. First FBX mesh name is used as part of the FBX node name. Content type, naming rules. Static mesh if override full name is enabled. Yeah, I definitely read this. This is okay. Silly me. Anyways. FBX Material Pipeline. Guide to transferring basic materials and textures with meshes using the FBX content pipeline on this page. The FBX pipeline transfers materials and textures applied to meshes, both static meshes and skeleton meshes, from 3D applications into Unreal. Simple materials can be converted by importing the textures used in source materials, thereby creating materials in Unreal with textures hooked up to the appropriate channels, and then, finally, applying the materials to the imported meshes. The FBX pipeline streamlines the mesh import process by automating what used to be a manually intensive process. The Unreal Engine FBX import pipeline uses FBX 2020.2. Using a different version during export may result in incompatibilities. This page includes information on both Autodesk Maya and Autodesk 3ds Max. Please choose your preferred content creation tool below. The tool's relevant information will then be displayed. Material support. Only basic materials are supported for import with the FBX pipeline. The types of materials that can be transferred are surface anisotrophic, Blinn, Lambert, Phong, Phony, standard multi-sub-object. In addition to these material types, only specific features of those materials can be transferred. The FBX material pipeline does not transfer individual settings. that does support the transfer of certain maps or textures used by the materials. Currently supported maps, textures being imported with the mesh, will be added to the material, and some common types will be connected to their default inputs on the material, but some will require manual connections. Furthermore, the more uncommon map types may not be imported at all, such as using the diffuse channel in Maya for ambient occlusion. Multiple materials. Mesh can have several materials applied to them, each covering certain faces of the mesh. And the FBX pipeline has the ability to handle the import meshes with several materials, assuming they have been set up correctly in the 3D application. Mine is pretty straightforward when it comes to the use of multiple materials on a mesh. You simply select the faces of the mesh you want to have the material applied to, then apply the material. A material will be created in Unreal Editor for each material applied to the mesh in Maya. The imported mesh will have material slots for each of these materials. When applied to the mesh, the materials will only affect the corresponding polygons of the mesh, just as they did in Maya. In 3ds Max, multiple materials are handled by the use of a multi-sub-object material. Each face of a mesh has a material ID. Each standard material within the multi-sub-object material is applied to the corresponding material ID. Material will be created in Unreal Editor for each of the standard materials within the multi-sub-object material, and the imported mesh will have material slots for each of these materials. When applied to the mesh, the materials will only affect the corresponding polys of the mesh, just as they did in 3ds Max. Material naming. Materials created by Unreal Editor during the import process will be named the same as the source materials in the 3D application. Where the name is pulled from depends on which application exported the mesh. Coming from Maya, the material name in the Unreal Editor is transferred from the name of the shading engine applied to the mesh in Maya. Coming from 3ds Max, the material name in Unreal Editor is transferred directly from the name of the material applied to the mesh in 3ds Max. Material ordering. As of 4.14, the skin naming convention is no longer required except by material order. When materials are initially imported from an FBX, the material name is assigned to the material slot, so that when you re-import your FBX, the original import material name can be used to match up the materials to the correct element index. This method is much more consistent than using the skin naming convention to order your materials, guaranteeing that the import process looks directly at the name in the FBX file to determine which selections should match up with the existing materials already populated in the list. And the slot name here will match the material drop down selection in the level of detail sections of your meshes. If you hover over the text for a slot name, the tooltip will list the name of the material that was imported. Any static meshes or skeletal meshes that were imported prior to 4.14 will be given a material name of none in the tooltip. Adding or removing material slots. To add or remove any material slots, use the Add button at the top of the materials list and remove X button next to the slot name. Added slots can be used to override the lower LOD sections, but not the base LOD. Setting materials slots in blueprints in C++. You can set your material on a component at runtime using the slot name you gave your material by calling set material by name. This saves you from having to hardcode material elements index number to retrieve the material slot you're looking for. It also ensures that your gameplay code still works properly if the order of materials on the meshes were to ever change, since it references the slot name instead. Texture import. If a material has texture assigned as either the diffuse or normal map in the 3D application, those textures will be imported to Unreal as long as the texture import textures setting is enabled in FBX import properties. A texture sample expression will be built in newly created material in Unreal Editor, and the imported texture will be assigned to that texture sample. A texture coordinate expression will also be added to the material and connected to the UV's input of the texture sample. However, you'll need to connect some textures to their material slots. If the textures applied to the material in the 3D application are in a format that is not compatible with Unreal, or are connected to an unknown material attribute, for example, diffuse in Maya, they will not be imported in this case. And also, if no textures were present in the material to begin with, material in Unreal Editor will be populated with a randomly colored vector parameter. Importing materials reference guide for importing materials. We're using reference images from 3ds Max and Maya throughout this reference guide, although there are other 3D modeling applications available for your use. This reference guide only covers 3ds Max and Maya. The Unreal Engine FBX import pipeline uses FBX 2020.2. Using a different version during export may result in incompatibilities. Choose your 3D art tool. Supported materials. Unreal's FBX pipeline supports the following materials: surface, anisotropic, blend, Lambert, Pong, phony, standard multi-sub object. Only base materials supported by Unreal's FBX pipeline. Uncommon map texture types will not be supported. Material naming. Unreal names materials in correlation with the originating application. For Maya, the material name in Unreal Editor is transferred from the name of the shading engine applied to the mesh in Maya. For 3ds Max, the material name in Unreal Editor is transferred directly from the name of the material applied to the mesh in 3ds Max. Material ordering. If material order is important, content creators can specify important material order by using the skin naming convention. For example, order can be established by naming materials accordingly. Example mesh skin 00. Example mesh skin 01. Putting meshes with simple materials. Unreal's FBX pipeline can import meshes with multiple materials. Maya is pretty straightforward when it comes to the use of multiple materials on a mesh. You simply select the faces of the mesh you want to have the material applied to, and then apply the material. The material will be created in Unreal Editor for each material applied to the mesh in Maya, and the imported mesh will have material slots for each of these materials. When applied to the mesh, the materials will only affect the corresponding polygons of the mesh, just as they did in Maya. For 3ds Max, multiple materials are handled by the use of a multi-sub object material. Each face of the mesh has a material ID, and each standard material within the multi-sub object material is applied to the corresponding material ID. Material will be created in Unreal Editor for each of the standard materials within the multi-sub object material, and the imported mesh will have multiple materials for each of these materials. When applied to the mesh, the materials will only affect the corresponding polys of the mesh, just as they did in 3ds Max. Importing textures. If the material has a texture assigned as either a diffuse or normal map in the 3D application, those textures will be imported into Unreal as long as the import textures setting is enabled. Creating and importing FBX morph target pipeline. Creating and importing morph targets for skeletal meshes using the FBX content pipeline. Morph target is a snapshot of vertex locations for a specific mesh that have been deformed in some way. For instance, you can take a character model, reshape their face to create a facial expression, and save that edited version as a morph target. Unreal, you can blend the morph target to cause the character's face to make that expression. Morph targets can be imported to Unreal via FBX and will be encapsulated within an animation sequence. This makes it very easy to import complex morph target animations into Unreal, since you can have any number of morph targets driving a single animation. For instance, you could use morph targets in your animation package to animate a character speaking some dialogue. Animation package, this may use any number of morph targets to capture the full motion of the face. However, when imported, the result will appear to be just a single animation sequence. You will still have access to the animation data for each morph target via curves. Morph target support in the FBX import pipeline provides an easy method for creating morph targets for skeletal meshes from theory applications into Unreal for use in games. Pipeline allows for any number of morph targets for any number of skeletal meshes to be imported within a single file. This page is a technical overview of using the FBX content pipeline to import morph targets into Unreal. Unreal Engine FBX import pipeline uses FBX 2020.2. Using a different version during export may result in incompatibilities. This page includes information on both Autodesk Maya and Autodesk 3ds Max. Please choose the preferred content creation tool below. The information relevant only to the chosen tool will be displayed. Choose your 3D art tool. Autodesk Maya, Autodesk 3ds Max. Naming: when importing morph targets into Unreal using the FBX format, the individual morph targets will be named according to the names of the blend shapes or morphs in the 3D application. The name will be the name of the blend shape added to the name of the blend shape node, i.e. blend shape node, blend shape. The name of the channel in the morpher modifier. Setting up morph targets. Setting up morph targets in Maya will be exported to FBX requires the use of blend shapes. The steps below provide a brief explanation of steps necessary to set up a morph target for export. Refer to the help files for the application for more detailed information. Start with the base mesh. 2. That was 1. 2. Duplicate the mesh that will be modified to create the target pose. In this case, it is the head to create the target pose. For this example, the target pose is character winking. 3. Select the target mesh and then the base mesh in that order. 4. In the Create Deformers menu of the animation menu set, select blend shape. The target mesh can be deleted after the step if desired. 5. The blend shape node is now visible in the base mesh's properties. These are the names that will be used in Unreal. You can change the names of the blend shape node and the blend shape here. 6. Adjusting the blend shape weight up to 1 causes the base mesh to interpolate toward the target pose. Setting up morph targets in 3ds Max to be exported to FBX requires the use of the morpher modifier. The steps below provide a brief explanation of the steps necessary to set up a morph target for export. Refer to the help files for the application for more detailed information. 1. Start with the base mesh. 2. Duplicate the base mesh that will be modified to create the target pose. In this case, it is the head. Create the target pose. For this example, the target pose is a character winking. 3. Add a morpher modifier to the base mesh. This needs to be before the skin modifier in the stack. 4. Within morph channel you want to populate selected. Press the pick object from scene and the morpher modifier's property roll out, or right-click the channel and choose pick object from scene. 5. In the viewport, click on target mesh. On the target mesh. 6. The morph channel is now populated and displays the name of the target mesh. This is the name that will be given to the morph target in Unreal. You can change it in the channel parameters section of the morpher modifier's rollout. 7. Adjusting the channel's weight up to 100 causes the base mesh to interpolate toward the target pose. Exporting morph targets. 1. Select the base meshes and joints to be exported in the viewport. In the File menu, choose Export Selection or Export All if you want to export everything in the scene regardless of selection. 3. Choose location and the name of the FBX file to export the morph target. 2. And set the appropriate options in the FBX export dialog. For the purposes of exporting morph targets, you must enable the animations checkbox in all the deformed models options. Click the Export Selection button to create the FBX file containing the morph targets. Select the base material, base meshes, and bones to be exported in the viewport. 2. In the File menu, choose Exported, Export Selected, or Export All if you want to export everything in the scene regardless of selection. Choose location and name for the FBX file to export the morph target and then click the Save button. That's a creepy face. Set the appropriate options in the FBX export dialog. For the purposes of exporting morph targets, you must enable the animations checkbox in all the deformations options. Trees. Click the OK button to create the FBX file containing the morph targets. Importing morph targets. The FBX morph target import pipeline allows for importing both a skeleton mesh and morph target all at once. If you add morph targets to an existing skeleton with morph targets already applied, the existing ones will be overridden. Skeletal mesh with morph targets. Click the Import button in the content browser. Navigate to and select the FBX file you want to import. The file browser that opens. Note, you may want to select FBX skeletal meshes.fbx in the drop-down filter to filter out unwanted files. 2. Choose the appropriate settings in the import dialog. Make sure that import mesh morph targets is enabled. Note the name of the imported mesh will follow the default naming rules. See the FBX import dialog section for complete details of all the settings. 3. Click the OK button in the import mesh and LODs. Resulting level of details. Resulting mesh morph target set. Materials and textures will be displayed in the content browser if the process was successful. You can see the morph target set that was created to hold morph target was named after the root bone of the skeleton by default. By viewing the imported mesh in Persona and using the morph target previewer tab, you can adjust the strength of the imported morph target, see that it is working as expected. The affected morph targets is often subtle, but the control it offers the animator and the believability it adds to the character cannot be overstated. FBX Scene Import. Using import into level to bring full FBX scenes into Unreal Engine. The import into level command enables users to import full FBX scenes into their levels instead of importing assets individually. Users are given full control of exactly which assets will be imported, as well as per asset control over import settings. The workflow also allows for selective re-importing for individual assets that receive further edits outside of Unreal. At this time, FBX Full Scene Import supports the following asset types: static meshes, skeletal meshes, animations. Materials basic support may not match original material in your content creation app. Textures, rigid mesh, morph targets, cameras, no animation, lights. In order to re-import your scene later, you must import your scenes as a single blueprint containing components for each asset in the scene. FBX full scene workflow. From the main menu bar, choose File, Import into Level. 2. Select the FBX file containing the scene you wish to import. 3. Choose the destination folder in your Unreal project. 4. Using the FBX scene import dialog, select the assets, static meshes, skeleton meshes, and materials from the scene you would like to import. You may also select the final output of the import process, putting all the selected FBX scene assets as individual level actors, components of a single actor, components of a single blueprint actor class. This is the only method that supports full scene re-importing. Once you have imported your FBX scene, all the assets will be imported into your project, along with an FBX scene data asset. This asset contains all the linking information between the original FBX scene and all the assets that were just imported into your project. FBX scene import options dialog. The FBX scene import options dialog gives you complete control over which assets will be imported into your scene and which will be included final output assets. You can also establish name groups of specific import settings and quickly assign them to the objects in your scene. The scene tab is where you can control how each of your FBX scene will be imported. The left side includes a tree view of the scene hierarchy. The right includes general import options for the entire scene. It's important to note that unchecking an asset in the tree view of the scene tab would not prevent that asset from being imported. It only prevents the asset from being included in the final output, level actors, single actor components, or blueprint. In order to completely prevent an asset from being imported, you must uncheck it in both the Scene tab and the Static Meshes or Skeleton Meshes tab, respectively. This workflow enables you to import assets from the scene that you may use eventually. Available options. Option description. Create content folder hierarchy. This will automatically create a folder representing each tier in the hierarchy. The folder will be named after the first item found at that hierarchy level. Import as dynamic. If checked, the mobility of all actors' components will be dynamic. If unchecked, they will be static. Hierarchy type. This is where you choose the final output of the import process. Blueprint asset. This creates a single blueprint actor. All the assets selected in the tree view. Hi, Buster. He's outside. All assets selected in the tree view will become components of the this blueprint actor. This is the only hierarchy type that supports full scene re-importing. Don't we think? Not as thick as the other one, though. Actor component. This will create a single actor that with each of the selected assets from the tree view imported as its components. This type does not support re-importing actors. This option will import each of the assets in the tree view as individual actors. This type does not support re-importing. Static Meshes tab. The Static Meshes tab contains all options for importing the various static meshes found in your FBX scene file. On the left is a list of all of this included meshes. We can uncheck meshes that you do not want imported. On the right side of the static mesh import options, this tab includes the ability to create presets of import options that can be quickly applied to groups of static meshes in the list view. The options found are similar to those in the standard static mesh import options. Static Meshes tab also includes the ability to create sets of override options, which will be covered in the Options Override section. Skeletal Meshes tab. The Skeletal Meshes tab will show all the skeletal meshes being imported into the scene from your FBX file. On the left is a list of all the included skeletal meshes. As with the Static Meshes tab, you can uncheck any meshes you do not wish to import. The right side contains a list of options for each of the skeletal meshes being imported, and is very similar to the standard skeletal mesh import options. The Skeletal Meshes tab also includes the ability to create sets of override options, which will be covered in the Option Override section. Materials tab. The Materials tab enables control over materials that are being imported into your scene along with your FBX file. You can also right-click in an existing material from the FBX file and replace it with an existing one in your project. Keep in mind that the FBX importer never allows you to override materials that already exist in the project. You can only assign existing materials to replace those in the FBX, or it will create new materials with basic texture hookups. Also, the Materials tab, on the Materials tab, you can override the location of where to save all materials. Click the Browse option and find where in your project you would like to import your materials to. Option Overrides. Option overrides can be used to group sets of import options into a named set, which can then be applied to multiple assets simultaneously. This allows users to quickly create sets of common options for groups of meshes rather than having to set them all one at a time. Create and apply an option override. Click the override button found in either the Static Meshes or Skeletal Meshes tab. 2. Enter a name for the new override. 3. With the new override selected from the dropdown at the top of the options list, set your desired options. 4. Select any number of meshes from the list on the left of the tab, then right-click and choose your new override from the context menu. You may also remove any selected override by clicking the Delete button located above the options list. Full scene reimporting. If you have imported your scene as a blueprint object, you also have the ability to do a full scene reimport. This works very similarly to the full scene import functionality, but also tells you what components of your FBX scene have been added, removed, or edited. Using full scene reimport, it is easy to return to your DCC app, make any desired changes, and then bring your complete scene back into Unreal, successfully applying only the changes you wish to update. Scene reimport workflow. To reimport your scene, right-click on FBX Scene Import Data Asset for any assets imported by a previous scene import, and then choose Reimport from the context menu. I don't know where I got meshes from. This will open the FBX Scene Reimport Options dialog. This dialog is similar to the FBX Scene Import Options, but will also show any assets that have been removed. The icons will have a minus, and assets which have been added. The icons will have a plus sign. The scene asset tree view can also be filtered to show you which assets in your FBX scenes have been added, removed, or changed. The dialog consists of the same 4 tabs as before: Scenes, Static Meshes, Skeletal Meshes, Materials, Report List, Filter buttons. All the button tabs of the SPX Scene and Report options dialog contain a series of filters for quick access to change assets. These filters include Option Description Add. This will automatically create a folder representing each tier in the hierarchy. The folder will be named after the first item found at that hierarchy level. Delete. This only shows those assets in the FBX scene that have been removed since the last import. Overwrite. This shows only assets that will be overwritten from the last import. Diff. This shows only assets that are different, added or deleted from the last import. Reimport Scene tab. The Reimport Scene tab is essentially the same as the Scene tab from the original import into level operation. However, a key difference is the ability to reimport the hierarchy. When the reimport hierarchy checkbox found at the top of the options group is checked, this reimports the blueprint's hierarchy, causing you to lose any changes you've made to the components list of the blueprint. Any node graph changes you make to the blueprint will be maintained. Reimport Static Meshes tab. The Reimport Static Meshes tab offers the same functionality as the standard Static Meshes tab found in the FBX scene.import dialog, now applied to the meshes being reimported. You can also filter the results using the filter options. Reimport Skeletal Meshes tab. The Reimport Skeletal Meshes tab offers the same functionality as the standard skeletal offers the same functionality as the standard skeletal meshes tab found in the FBX scene import dialog, now applied to the meshes being reimported. You can also filter the results using the filter options. Reimport Materials tab. To reimport Materials Meshes tab offers the same functionality as the standard meshes and materials found in the FBX scene import dialog, now applied to materials that are part of the FBX scene being reimported. However, the importer will never overwrite existing material. FBX Skeletal Mesh Pipeline. Setting up, exporting, and importing skeletal meshes using the FBX content pipeline. Skeletal Mesh supports the FBX import pipeline, provides a streamlined workflow for getting. I think, yeah. Yeah. See me struggling. Look at this bitch. Sitting sideways, riding dirty. Give me riding dirty. Give me riding dirty. Yeah. I gotta get back on it. Oh yeah, whatever. Skeletal Mesh support in the FBX import pipeline provides a streamlined workflow for getting animated meshes from 3D applications into Unreal for use in games. For addition to the meshes being imported, animations and morph targets can be transferred using the FBX format, all within the same file if desired. Also, the textures, views, and normal map only used in the materials applied to those meshes in the 3D application will be imported, and materials will be automatically created and applied to the imported meshes. Features supported for importing self meshes using FBX materials, including textures, animations, morph targets, multiple UV sets, smoothing groups, vertex colors, LODs. Currently, only a single animation for each skeleton mesh can be imported in a single file. Multiple morph targets can be transferred for a skeleton mesh in one file, though. This page is a technical overview of using the FBX content pipeline to import skeleton meshes into Unreal. The Unreal Engine FBX import pipeline uses FBX 2020.2 using a different version during export may result in incompatibilities. In any case, below where the documentation tells you to use the import asset button, you can also just click and drag the FBX file into your OS's file browser. This page includes information on both Autodesk Maya and Autodesk 3ds Max. Please choose your preferred content creation tool below, and the information relevant only to the chosen tool will be displayed. General setup: single mesh versus multi-part mesh. Skeleton meshes can be comprised of a single contiguous mesh, or they can be made up of several separate meshes, all skinned to the same skeleton. Using multiple meshes makes it possible to load individual parts differently, as well as exporting parts separately for use in modular character systems. There is no performance penalty for creating your skeleton meshes this way. The individual parts are all combined when being imported into Unreal Editor. Rigging. Rigging refers to the binding of a mesh into a skeletal hierarchy of bones joints. This allows the bones joints of the underlying skeleton to influence the vertices of the mesh, deforming it as they move. Skeleton in Maya, you will generally use the joint tool to create the skeleton for your skeletal mesh. Again, there are endless tutorials on using this tool in creating rigs in Maya. The Maya help is also a good source of information on the subject. How you go about creating skeletal hierarchies in 3ds Max is up to you. You may use the standard bones tools as they work quite well, or create your own hierarchy of objects to allow for completely custom geometry and controls. There are many ways to skin a cat, pardon the pun. Tons of tutorials out there that show how to create animation rigs for game characters. You can also refer to 3ds Max help for complete details on how the tools work. Binding. In Maya, the meshes are bound to the skeleton using the smooth bind command. The process is the same whether the skeleton mesh consists of a single complete mesh or is made up of multiple mesh parts. 1. Select the meshes to be bound. 2. Select the root joint of the skeleton. 3. Select the smooth bind from the skin menu. 4. Now you can adjust the weights of the vertices of the mesh for each joint to determine which vertices are influenced by which bones and to what degree. This can be done using the paint skin weights tool or whichever method you prefer. In 3ds Max, meshes must be bound to the skeleton using the skin modifier. The process is the same whether the skeleton mesh consists of a single complete mesh or is made up of multiple mesh parts. 1. Select the mesh to be bound. 2. Add a skin modifier from the modifier list. In the parameters rollout of the skin modifier, click the Add button to add the bones that influence the mesh, and the Select Bones window will open. 4. Select the bones in the Select Bones window and click the Select button to add the bones. 5. Bones are now displayed in the bones list of the modifier. 6. You can now adjust the weights of the vertices of the mesh for each bone to determine which vertices are influenced by which bones and to what degree. This can be done using envelopes, directly entering the weights of the vertices, or whichever method you prefer. Pivot point. The pivot point of the mesh in Unreal Engine determines the point around which any transformations, translation, rotation, scale will be performed. The point of skeletal mesh is always located at the root bone joint of the skeleton. This means it does not matter where the root of the skeleton is located within the scene. It will be as though it is at the origin when exporting 000 when exporting from a 3D modeling application. Triangulation. Meshes in Unreal Engine must be triangulated. I'm doing the dishes at this point in the video, I believe. There are several ways you can ensure your mesh is triangulated. Maybe not. Model the mesh with only tries. Best solution provides the most control over the end result. Triangulate the mesh in the 3D application. Good solution allows cleanup and modification before export. Allow the importer to triangulate the mesh. Okay solution allows no cleanup but can work for simple meshes. Allow the IPX exporter to triangulate the mesh. Okay solution allows no cleanup but can work for simple meshes. Note, allowing the FBX exporter to triangulate the mesh results in completely random smoothing. Split non-matching triangles is checked. Importing an FBX triangulated mesh back into Maya and re-exporting shows proper smoothing. It will always be best manually triangulate the mesh in the 3D application, controlling the direction and placement of edges. A mesh triangulation can lead to undesirable results. Creating normal maps. Normal maps can be created for your meshes directly inside of most modeling applications. Creating both a low-res render mesh and a high-res detail mesh. Geometry of high-res mesh. High-res detail mesh is used to generate the normals for normal map. Epic uses a workflow internally and uses XNormal into the process and generally results in much better results than when rendering inside of Unreal Engine 4. For details on this process, see textures. Materials applied to meshes modeled in external applications will be exported along with the mesh and when imported into Unreal. This streamlines the process as textures do not need to be imported separately in Unreal and materials do not need to be created and applied, etc. The imported process is capable of performing all of these actions when using the FBX pipeline. These materials also need to be set up in a specific way, especially when the mesh has multiple materials or the order of materials on the mesh is important. Like for character models, when materials needs to be the body and material 1 needs to be the head. For complete details on setting up materials for export, see the FBX material pipeline page. Vertex colors. The vertex colors, one set only for filter meshes, can be transferred using the FBX pipeline. No special setup is necessary. Export mesh from 3D app. The meshes can be exported individually or multiple meshes can be exported to a single FBX file. The import pipeline will separate multiple meshes, skeletal meshes into skeletal multiple assets within the destination package. Select the meshes and joints to be exported in the viewport. 2. In the file menu, choose export selection or export all if you want to export everything in the scene regardless of selection. Choose the location and name for the FBX file to export the meshes. 2. And set the appropriate options in the FBX export dialog and then click the export selection button to create the FBX file containing the meshes. 1. Select the meshes and bones to export it in the viewport. 2. The file menu, choose the export selected or export all if you want to export everything in the scene regardless of selection. 3. Choose the location and name for the FBX file to export the meshes and click the save button. 4. Set the appropriate options in the FBX export dialog and then click the OK button to create the FBX file containing the meshes. Mesh, import mesh. 1. Click the import button in the content browser. Navigate to select the FBX file you want to import in the file browser that opens. Note, you may want to select FBX skeletal meshes.fbx in the drop-down to filter out unwanted files. Yoga ball fart. The path of the imported assets depends on the current location of the content browser when importing. Make sure to navigate to the appropriate folder prior to performing the import. You may also drag the imported assets into a new folder once import is complete. Choose the appropriate settings in the FBX import options dialog. The defaults should be sufficient when importing a mesh that does not share an existing skeleton. See the FBX import dialog section for complete details of all the settings. And the skeleton mesh being imported if the skeleton mesh being imported shares existing skeleton, click the select skeleton drop down menu, select the skeleton asset from the list. 3. Click the import button to import the meshes. The resulting mesh, as well as the materials and textures, if those options were enabled, are displayed in the content browser if the process was successful. By viewing the imported mesh within Persona, you can determine that the process worked as expected. Skeleton mesh level details. Skeleton meshes can make use of levels of detail in game in order to limit the impact of meshes as they get further from the camera. Generally, this means each level of detail will have a reduced number of tries, simpler skeleton, and perhaps a simpler material or materials applied to it. The FBX pipeline can be used to import these LOD meshes. LOD setup. In general, LODs are handled by creating models of varying complexity, going from the full detail based mesh to the lowest detail level LOD mesh. These should be aligned and occupying the same space with the same pivot point, and should all be skinned to the same skeleton. And this is where my dad walked in. It's also possible for skeleton meshes to be made up of multiple individual meshes within the 3D application. Each of these parts can have LODs independent of the rest of the mesh. This means that some parts have simplified versions and different LODs, while other parts continue to use higher detail versions. Each LOD mesh can have completely different materials assigned, including different amounts of materials. This means the base mesh could use multiple materials to give the desired amount of detail up close. And then I make mac and cheese and then the video and come back because I didn't want to have an hour of blah. Would have taken an hour though. It's like a half hour. Really should have just kept recording. Lower detail meshes could use a single material since details will be less noticeable. Select all the meshes, base plus LODs, in order from the base LOD down to the last LOD. This is important so that they are added in the correct order in terms of complexity. Then select the level of detail group command and from the edit menu. 2. You should now have the meshes all grouped under the LOD group. 1. Select all of the meshes, base plus LODs. The order is not important. Then select the group command from the group menu. 2. Enter a name for the new group in the dialog that opens the click the okay button to create the group. 3. Click the button to view the utilities panel, then choose the level of detail utility. Note you may need to click more and select it from the list. With the group selected, click the create new set button, create a new LOD set and add the meshes selected group to it. The meshes will automatically be ordered according to their complexity. Multi-part LODs. Setting up LODs for multi-part skeletal meshes is almost identical to setting up LODs for a full mesh, with the exception that each individual part that has LODs will have a LOD group created for it. Process for setting up these individual LOD groups is identical to the process outlined above. Export LODs. To export the skeletal mesh level details, 1. Select the LOD groups and then the joints to be exported. 2. Follow the same export steps used for the base mesh described above in the export mesh section. 1. Select the groups of meshes that comprise the LOD set and the bones to be exported. 2. Follow the same export steps used in the base mesh described above in the export mesh section. Import level details. Skeleton mesh level details can be imported easily through the mesh details panel in the persona under LOD settings. Open the skeleton mesh you wish to apply in a LOD 2 in LOD 2 in persona. Go to the mesh tab. To the mesh details panel, scroll down and find the LOD settings section. Click the LOD import option. 3. Navigate to and select the FBX file you want to import in the file browser that opens. 4. The imported LOD will be added to the mesh details panel. 1. Under each LOD screen size